The rule is one sentence long. A generic parenteral, ophthalmic or otic product must contain the same inactive ingredients at the same concentration as the reference product. Simple enough until that inactive ingredient is a polymer that only exists once it has been polymerized, cross-linked or cured inside the product. Hello, I am Raghuvar Singh Parmar, Director Scientific Affairs at Resolve Mass Laboratories, and we work with pharma and biotech teams to build the characterization data behind excipient sameness in complex generic filings. Today, what that data has to show for three of the hardest excipient classes: PLGA, cross-linked hydrogels, and PDMS elastomers. Before we start, I would request you one thing. If you have found anything valuable in this channel, please like this video and subscribe this channel. This gesture of appreciation would really means a lot to us. Now let's start. Q1 and Q2 sameness has been part of generic assessment for decades. What changed is the products. Mirena arrived in 2000 with levonorgestrel held in a PDMS reservoir. Ozurdex followed in 2009, then Dextenza in 2018, and Durista in 2020. In every one, the excipient is not a filler sitting next to the drug, it controls the release. PLGA alone is now the rate controlling excipient in more than 20 approved long-acting injectables and implants. So a generic that has to match the inactive ingredients is really being asked to match a release controlling polymer. Let's fix the definition first, because they are narrower than the words suggest. Q1 sameness means the same inactive ingredients. Q2 sameness means the same concentration. Neither term says anything about how the ingredient was made, what its molecular weight is, and how tightly it is cross-linked. For PEG, polyethylene glycol, carboxymethyl cellulose sodium, and ethylene vinyl acetate copolymer, that is fine. Name it, is state the amount, and the question is closed. The part we want to spend real time on is what happens when naming the ingredient tells the reviewer almost nothing. So here is the difference. With a simple excipient, the name and the grade describes the material completely. With PLGA, a cross-linked hydrogel or PDMS elastomer, two materials can carry the same name, same cache number, the same percentage in the formula, and still release drug on completely different timelines. That is why these three classes carry an extra ask on top of Q1 and Q2 comparative characterization data measured against the reference product. Now, PLGA first. Let's take PLGA first. It is the copolymer of lactide and glycolide that degrades by hydrolysis, and its release profile is set by a short list of properties. The comparative package covers the molar ratio of lactide to glycolide, the molecular weight, and the full weight distribution, and the polymer architecture. If reference uses a branched PLGA, a glucose quote star shape polymer, say you need branch analysis, not an average. Reviewers also look for end cap analysis, inherent viscosity, and glass transition temperature. And that is a practical limit. Ozurdex and Durista way under the milligram, so method sensitivity becomes really the constant here. So let's move on to cross-linked hydrogels. Now, what is cross-link hydrogels? The rules are a little bit different. Hydrogels change the question because the excipient does not exist as a self item. Dextenza is the clearest example. A dexamethasone ophthalmic insert built from 4-arm PEG and hydroxysuccinimidyl glutarate and tyrosine acetate, where the NHS ester reacts with primary amine groups to form the network. You cannot buy that gel, it forms during the manufacture. So for Q1, describe the starting material, their ratios and cross-linking method. For Q2, give the amount of each starting material. A Q2 difference can be justified usually through comparable mechanical properties as long as the amount raise no safety concern. Now, PDMS elastomers. PDMS elastomers work the same way and add a geometry problem. In Mirena, levonorgestrel sits in a PDMS reservoir behind a semi-opaque silicon membrane that also contains colloidal silica. Release depends on the polymer chemistry, on how densely the polymer is cross-linked, and on dimensions of the membrane. FDA-funded research has shown how much the curing route, addition versus condensation, and the fillers change both cross-link density and manufacturability. So the package needs three things together: composition, including degree of cross-linking and the quantity of each component, dimensions, meaning matched membrane length and thickness, and mechanical property data. Now, let's talk about building the sameness package. So, across all the three classes that we discussed, the workflow has the same shape. Characterize the reference product, characterize your own material with the same methods, compare, then justify that does not match. Two things decide whether the comparison holds up. Run test and reference side by side, same reference lot, same instrument, same session, because the data collected months apart is really hard to read as comparable. And meeting a USP limit is the specification result, not the sameness argument. At Resolve Mass, we have supported sponsors through exactly this kind of comparative work, where one unexplained shoulder on a molecular weight curve turned into a batch selection question and a free set of studies. Now let's talk about key takeaways from this discussion. So what should you walk away with? So Q1 and Q2 means the same ingredients at the same concentration and nothing more. For PLGA Hydrogels and PDMS, that alone will not answer the question. Each one needs comparative characterization of composition, structure, and mechanical behavior. And the comparison has to be run side by side to be readable. If you are working on this kind of complex generic projects in the pharmaceutical space, I would request you to contact Resolve Mass Laboratories if you need a CRO or CDMO partner. We would be happy to continue the discussions and working with you. Thank you so much for watching this session till the end. See you in the next one. Until then, goodbye for now. Before you go, I want you to do a few things. Number one, subscribe this channel right now. The more you subscribe, the more valuable pharma insights and expert tips and industry updates we can bring to you. Also, please comment your feedback. This will really help us to improve the content, quality of the videos, and many things. And finally, share this video to at least one person who you think this would really help them. Thank you so much, and I will see you in the next time. Until then, goodbye for now.